There is a continent at the bottom of the world that most people will never visit. It sits at the far southern edge of the planet, separated from every other landmass by thousands of miles of freezing ocean. No cities exist there. No permanent civilian population has ever settled on its surface. It is, by almost every definition, the most remote and least accessible place on Earth. And yet, for a location so distant and so empty, it has attracted a remarkable amount of attention over the years, not just from scientists and researchers, but from ordinary people asking ordinary questions that have not received ordinary answers. Antarctica covers approximately 14 million square kilometers. Roughly 98% of that surface is buried under a sheet of ice that, in certain regions, reaches depths of nearly 4 kilometers. That is not a thin layer of frost. That is an enormous, ancient mass of compressed ice that has been building up for millions of years. Beneath it lies a continent, an actual landmass with mountains, valleys, lakes, and geological formations. Most of that terrain has never been directly seen by human eyes. It has only been studied through instruments, sonar readings, and satellite imaging. What those instruments have returned is, for the most part, what scientists expected to find, but not entirely. For decades, governments, universities, and international research institutions have shared photographs, maps, and datasets about Antarctica with the public. Expeditions have been documented. Bases have been built. Scientific papers have been published. The general picture presented to the world has been one of a frozen, barren, scientifically valuable, but largely empty continent. Most people accepted that picture. There was little reason not to. The organizations providing the information were credible, the data appeared thorough, and the explanations seemed consistent. For a long time, the story of Antarctica felt complete enough that few people thought to look more carefully. But in recent years, something shifted. It did not happen because of a single discovery or a single announcement. It happened gradually, through a slow accumulation of photographs, satellite images, and observations that began circulating online and in independent research communities. Some of these images were pulled from publicly available sources, government databases, mapping platforms, historical archives. Others came from explorers and researchers who had visited the continent directly. What made these images unusual was not that they showed something impossible. It was that they showed things that did not fully match the explanations provided alongside them. Some of the photographs showed what appeared to be geometric shapes beneath the ice. Not rough or irregular formations of the kind one might expect from natural geological processes, but shapes with edges that seemed too defined, angles that appeared too consistent, and proportions that did not obviously correspond to known features of glacial movement or tectonic activity. These were not images taken with poor equipment or in low resolution. Several of them came from high-definition satellite captures. The shapes were visible. The question was simply what produced them, and that question, in many cases, went unanswered. Others showed what appeared to be straight lines across the surface or beneath it, long, consistent markings that extended across distances in a way that raised the obvious question of whether they were natural. Lines appear in nature, of course. Geological fault lines, ice ridges, and erosion patterns can all produce linear features on a surface. But some of the lines visible in these images did not match the typical characteristics of those known formations. They were too regular. They ran in directions that didn't align with the surrounding geography. And in a few cases, they appeared to converge or intersect in patterns that were difficult to explain through natural processes alone. A smaller number of images showed formations that cast shadows in unexpected ways, shapes rising from the surface or partially exposed through the ice that seemed oddly structured for a landscape shaped purely by wind, cold, and time. Again, the explanations offered were either general or absent. Researchers who raised these observations publicly were sometimes told that the shapes were the result of sastrugi, wind-sculpted snow formations, or that they were simply artifacts of the imaging process itself. But those explanations did not always hold up when examined in detail. Sastrugi do not typically produce the proportions visible in some of these images. Imaging artifacts tend to produce consistent patterns across an entire photograph, not isolated shapes in specific locations. This is where the situation becomes unclear. It is not that the images are necessarily showing something extraordinary. It is that the responses to questions about them have been consistently incomplete. When researchers, journalists, or curious individuals have asked for more specific explanations, the answers they received were often vague. In some cases, requests for additional data or higher resolution imaging of particular regions were not fulfilled. In other cases, areas that appeared on older maps with some level of detail were later shown on newer maps with those details removed or obscured. That detail sounds minor at first, until it is examined more closely. If the explanation for something is simple and natural, there is usually no reason to make that explanation difficult to access. It is worth being careful here about what is and is not being suggested. The existence of unexplained images does not automatically lead to any particular conclusion. Satellite imagery is complex. Interpretation is difficult. What looks geometric from one angle may be perfectly natural when seen in context. The history of exploration is filled with examples of people seeing patterns in landscapes that turned out to have mundane explanations. That possibility should not be dismissed. But the pattern of incomplete responses, not just in one instance, but across multiple observations from different sources over a period of years, is itself something that deserves attention. Antarctica has a complicated history when it comes to access and information. The Antarctic Treaty, signed in 1959 and now ratified by over 50 countries, established the continent as a zone of scientific cooperation. Under this agreement, no nation can claim territorial sovereignty, and military activity is restricted. Research stations from multiple countries operate there, and in principle, information gathered on the continent is meant to be shared openly. But the treaty also gives individual nations and institutions significant control over which areas can be visited and how data from those areas is handled. Not every region of Antarctica is equally accessible. Some areas are designated as specially protected zones, meaning entry is restricted. The reasons given for those restrictions are typically environmental, protecting fragile ecosystems from contamination. But that explanation raises its own questions when applied to regions of the continent that appear, from the outside, to contain little more than ice. There is also the matter of timing. Several of the unusual images that drew attention in recent years were taken during or after periods when new satellite technology made it possible to see the continent at higher resolution than ever before. This means that some of what people are now observing may have been present all along, simply invisible at lower resolution. That could mean that natural features are now appearing more defined and therefore more ambiguous than they actually are. But it could also mean that features which were previously too small or too faint to detect are now becoming visible for the first time. Both interpretations are possible. The problem is that the institutions best equipped to distinguish between them have not consistently offered detailed public analysis of the specific formations in question. Some researchers who have studied polar geology suggest that certain subglacial formations can produce surface expressions that look unusual when viewed from above. The ice is not static. It moves, flows, and compresses over time, and those movements can create ridges and depressions that reflect the shape of whatever lies beneath. If something with a regular structure existed under the ice, whether a geological formation, an ancient topographical feature, or something else, there's a theoretical basis for that structure to leave an imprint on the surface that a satellite might detect. This does not confirm anything specific, but it does mean that the argument of pure impossibility is not as clean as it might seem. The images are showing something. The debate is about what that something is. At first, much of this discussion existed only in fringe spaces, online forums, independent documentary channels, blogs run by people outside mainstream research communities. That made it easy for the scientific establishment to dismiss the questions without engaging with the specific evidence. And some of that dismissal was probably warranted. There's a great deal of misinformation that circulates about Antarctica, including claims that are easily disproven and theories that have no evidentiary basis. However, as higher quality imaging became more widely available and as more people with legitimate research backgrounds began examining the same photographs, the conversation changed slightly. It became harder to dismiss the specific visual anomalies as simple misidentification or wishful thinking, because more careful observers were asking the same questions and arriving at the same points of uncertainty. There's also the historical dimension. Antarctica was not always covered in ice. Geological and paleoclimatic evidence indicates that millions of years ago the continent had a very different environment, one with liquid water, vegetation, and conditions that could have supported life. This is not disputed. It is accepted science. What is less clear is the exact timeline of how and when the ice coverage developed, and whether there were any periods during that transition when conditions on parts of the continent were significantly different from what they are today. Some older maps, including the famous Piri-Reis map of 1513 and the Orontius-Phineas map, have been claimed by certain researchers to show features of the Antarctic coastline that should not have been known to cartographers at that time. The mainstream explanation is that these maps are misinterpreted or that the similarities are coincidental. But the maps exist, the claims have been made by credible scholars, and the debate around them has never been fully resolved. This is not a story with a clean ending. It is not that story. The photographs exist, and they show things that have not been fully explained. The questions exist, and they have not been fully answered. The historical records are ambiguous in certain areas, and the access restrictions that govern parts of Antarctica create an environment where independent verification is genuinely difficult. None of that proves anything specific, but it does mean that the picture of Antarctica as a fully understood, fully documented, and fully transparent subject is not entirely accurate. What is accurate is this. There are features visible in satellite and aerial photography of Antarctica that do not have clear, publicly available explanations. There are researchers who have raised questions about those features and received responses that were incomplete. There are areas of the continent where access is restricted in ways that go beyond straightforward environmental protection. And there's a long history of maps, records, and observations related to Antarctica that have not been fully reconciled with the standard account of the continent's past. Whether those observations lead anywhere significant is something that cannot be answered from the available evidence. But the questions themselves, the specific, visual, documented questions, are not easy to set aside. They sit there, attached to images that anyone can look at, pointing toward explanations that have not yet been given clearly. And for a continent so remote, so controlled, and so rarely visited by anyone outside a small circle of authorized researchers, that absence of clear explanation is, by itself, something worth paying attention to. According to official sources, Antarctica is one of the most thoroughly studied landmasses on the planet. That statement on its surface is entirely accurate. Since the mid-20th century, dozens of countries have maintained active research stations on the continent. Scientists from fields as varied as glaciology, atmospheric science, marine biology, geology, and astrophysics have spent months, and in some cases years, working in Antarctica. The data collected there feeds into climate models, oceanic research, and planetary studies. By most institutional measures, Antarctica is not a place of mystery. It is a place of science, and the official position reflects that clearly and consistently. The research infrastructure that exists on the continent is genuinely substantial. There are over 70 active research stations spread across Antarctica, operated by countries including the United States, Russia, the United Kingdom, Australia, China, Argentina, and many others. The largest of these, the American Amundsen Scott South Pole Station, operates year-round and houses dozens of researchers even during the brutal Antarctic winter. These are not temporary outposts. They are equipped laboratories, capable of conducting complex measurements and transmitting data continuously to institutions around the world. The existence of this infrastructure is often cited as evidence that the continent is well understood, that if something unusual were present, the people working there would know about it. When questions arise about unusual formations or strange shapes visible in photographs of Antarctica, official sources offer a consistent set of explanations. The first and most frequently cited is the effect of natural geological and environmental processes operating over vast stretches of time. Wind, in particular, is one of the most powerful forces shaping the Antarctic landscape. The continent experiences some of the strongest, sustained winds recorded anywhere on Earth. In coastal and elevated regions, winds regularly exceed 100 kilometers per hour and, in extreme events, can reach nearly 300. Over thousands of years, Those winds carve and reshape ice and exposed rock in ways that can produce remarkably symmetrical, angular, and geometric-looking patterns. The process is gradual but cumulative. What looks deliberately shaped may simply be the product of consistent wind direction acting on a surface over an enormous period of time. A related explanation involves pressure ridges. The Antarctic ice sheet is not a single static mass. It moves. Glaciers flow toward the coast at varying speeds, and where different sections of the ice sheet meet or press against fixed geological features, immense pressure builds up. That pressure can force the ice upward, creating ridges, folds, and angular formations along the surface. These features can extend for kilometers and can appear, from above, as unnaturally straight or geometric. Pressure ridges are well-documented phenomena in polar science. They have been studied extensively, and their formation is understood in considerable detail. When researchers look at satellite images showing linear features in the Antarctic ice, pressure ridges are often the first explanation offered, and in many cases, the explanation holds up. Then there's the role of satellite imaging technology itself. This is an important part of the official explanation, and it deserves careful consideration. Satellite cameras capture images by recording reflected light across different wavelengths. Ice is one of the most reflective surfaces on Earth. When sunlight strikes a flat or gently curved ice field at a low angle, which happens frequently in polar regions where the sun sits close to the horizon, the resulting image can distort the apparent shape of features on the surface. What is actually a gentle slope may appear as a sharp edge. A rounded ridge may look like a defined geometric corner. These are not failures of the technology. They are expected consequences of imaging a highly reflective surface under specific lighting conditions. Scientists who work with polar satellite data are trained to account for these effects, and they do so routinely. Compression artifacts add another layer of complexity. When satellite images are processed, transmitted, and stored, they undergo digital compression. That process can introduce visual anomalies, edges that appear sharper than they are in reality, shapes that seem more defined, and patterns that look almost structured. Anyone who has ever zoomed into a heavily compressed photograph and seen blocky, artificial-looking shapes at the pixel level has encountered a mild version of this effect. In satellite imagery of vast, visually uniform landscapes like Antarctica, where the camera is looking for subtle differences across a largely white or gray surface, these compression artifacts can be especially pronounced. That is the technical explanation, and technically it is sound. Some of the specific images that have drawn the most public attention have been addressed more directly by researchers. A category of formation that appears repeatedly in these discussions is the nunatak, a rocky mountain peak that protrudes through the surface of the ice sheet. Antarctica has thousands of them. They range in size from small outcroppings barely visible above the ice to large mountain peaks rising several hundred meters. From directly above, certain nunataks present a striking appearance. The rock is darker than the surrounding ice. The edges are often defined by the boundary between exposed stone and glacial surface, and the shape can look surprisingly angular or even pyramidal. Several of the images circulating online that have been described as showing unusual structures are, according to geologists, simply nunataks photographed from above. The Antarctic Pyramid Formation, a mountain in the Ellsworth Range that attracted significant attention after photographs of it spread widely, was identified by researchers as a pyramidal horn, a natural geological feature formed by glacial erosion from multiple sides. That explanation was publicly issued. It was specific, it referenced known geological processes, and it addressed the image directly. At first, that seems like a clean resolution, and for that particular image, it may well be. But this is where the overall explanation becomes slightly more complicated. The fact that one widely discussed image has a clear explanation does not automatically resolve the questions surrounding all of the others. The official position tends to address the most prominent and most widely circulated examples. It is less consistent in addressing images that are less well known, or formations that appear in regions of Antarctica that receive less public attention. And when the explanations are applied broadly, when researchers say, in general terms, that all unusual formations in Antarctica are the result of wind, pressure, imaging artifacts, or nunataks, that blanket statement is harder to evaluate because it is not attached to specific analysis of specific images. This is worth pausing on. The official explanation is not vague in its individual components. Each element, wind erosion, pressure ridges, imaging distortion, nunatax, is well defined, scientifically grounded, and supported by decades of polar research. The problem is not with any single part of the explanation. The problem is in how comprehensively that explanation is applied. When a specific formation is examined and identified, that is science. When the same explanation is extended to cover everything, without case-by-case analysis, that is something closer to a default assumption. And default assumptions, even when generally correct, can miss things. It is also worth considering who is in a position to verify the official explanations. Antarctica is not a place that independent researchers can simply visit to check the data. The Antarctic Treaty governs access to the continent, and while it is framed as an agreement promoting open scientific exchange, the practical reality is that access requires significant resources, institutional affiliation, and in some cases explicit authorization. An independent geologist who wanted to visit a specific region of Antarctica to examine a particular formation would face substantial obstacles, financial, logistical, and regulatory. That does not mean the official data is wrong, but it does mean that the ability to independently confirm or challenge that data is genuinely limited. In most areas of science, peer review and independent replication are fundamental to how knowledge is validated. In Antarctic research, that process operates within a much narrower circle of access than it does in most other fields. There's also a question about the consistency of the explanations over time. Some of the images that have been questioned were taken years or even decades ago. In a few cases, the areas shown in those images were subsequently mapped at lower resolution in newer publicly available datasets, meaning that whatever was visible in the original image became harder to see in later versions. The official explanation for this kind of change typically involves updated mapping methodology or different satellite platforms with different capture parameters. Those are plausible reasons, but it is not always possible to verify them clearly from the outside. And when an image that raised questions later becomes less accessible or less detailed in public databases, it does not resolve the question. It simply makes it harder to pursue. Some researchers who have studied the official explanations carefully have pointed out that the technical arguments, while valid in general, are not always applied consistently. The imaging artifact explanation, for example, is invoked for images that show geometric shapes, but similar imaging conditions in other parts of the world do not consistently produce the same kinds of shapes. If compression and reflective distortion were primarily responsible for the apparent geometry in Antarctic images, one might expect similar effects to appear regularly in satellite photographs of other glaciated regions, Greenland, the Himalayas, the Arctic. They do appear occasionally, but not with the same frequency or the same apparent regularity as in certain Antarctic images. That inconsistency is not a definitive argument against the technical explanation, but it is an unresolved detail that the explanation does not clearly account for. There is also the matter of how the official response is delivered. When mainstream scientific institutions address the unusual images from Antarctica, they tend to do so briefly, with general references to known phenomena, and without extensive engagement with the specific visual evidence being questioned. That approach may simply reflect the practical reality that researchers have limited time and that most of these questions originate outside peer-reviewed channels. But it also means that people asking detailed, specific questions rarely receive detailed, specific answers. The gap between the question being asked and the answer being given is often considerable, and in that gap, uncertainty naturally grows. None of this is to suggest that the official explanation is fabricated or deliberately misleading. The science behind wind erosion, pressure ridges, and imaging artifacts is real and well established. The researchers who have identified nunatax in widely circulated photographs are not inventing those identifications. The institutions operating in Antarctica are conducting legitimate research and producing valuable data. All of that is true, and it should be stated clearly. The issue is not whether the explanation has merit. It does. The issue is whether that explanation, as currently presented, is complete enough to account for everything that has been observed. The honest answer is that it is not entirely clear. Some images have been addressed well. Others have not been addressed in any specific way. Some regions of Antarctica have been studied in considerable detail. Others remain poorly mapped and rarely visited. The official explanation covers the general case well, but the general case and every specific instance are not the same thing. And the specific instances, the particular images, the particular formations, the particular areas where access is restricted or data is incomplete, are where the questions continue to sit without resolution. The explanation is detailed and reasonable, but not every image fits neatly within it, and that gap, however small it may appear in official terms, has not been fully closed. The geological explanation, taken on its own terms, is a reasonable one. Wind erosion is real. Pressure ridges are real. Satellite imaging distortion is real. These are not invented phenomena. They are documented, studied, and understood processes that genuinely shape the Antarctic landscape in ways that can look unusual to an untrained eye. When official sources point to these explanations, they are not making things up. They are drawing on a body of scientific knowledge that has been built over decades of polar research. And for many of the images that have circulated publicly, those explanations probably do apply. That should be acknowledged clearly before anything else. But the geological explanation has limits. It covers a wide range of cases, but it does not cover all of them equally well. And when those limits are examined carefully, the first real doubts begin to take shape. Not dramatic doubts, not accusations, but quiet, specific observations that do not resolve cleanly into the standard account. The process of examining those doubts carefully, without either dismissing them or exaggerating them, is where this investigation needs to go next. One of the clearest issues is scale. Not all of the formations visible in satellite imagery of Antarctica are small. Some of them are large, genuinely large. Certain geometric shapes that have appeared in publicly available satellite images span distances of several hundred meters, and in a few cases, appear to extend beyond a kilometer. That is not the scale of a typical wind-carved surface feature. Wind erosion produces remarkable patterns, but it tends to operate at a scale consistent with the surface it acts upon. A pressure ridge can extend for considerable distances, but it follows the movement of the ice. It curves. It varies in height. It responds to the irregular forces pressing against it. What has been observed in some images is different. The shapes appear consistent across their length. The edges hold their angle. The proportions remain stable across a span that, for natural surface features in a glacial environment, would be unusual. When researchers have been asked specifically about these large-scale formations, not about Antarctic imagery in general, but about the specific shapes in specific locations, the responses have tended to be general rather than specific. The answer comes back as a category: wind erosion, pressure dynamics, imaging effects. But the category is not the same as an analysis of the individual case. A formation that spans several hundred meters in a consistent geometric pattern is not self-evidently explained by saying that wind erosion is a real process. The explanation needs to account for the scale, the consistency, and the specific location of what is being observed. In many cases, that level of specificity has not been provided, and when it is absent, the general explanation begins to feel less like a conclusion and more like a placeholder. This is where it becomes important to think carefully about what a genuine scientific response to these observations would look like. If a researcher identified a specific formation, coordinates, dimensions, visible characteristics, and asked a relevant institution to explain it in detail, a thorough response would involve examining the specific site, checking it against subsurface data, comparing it to similar features elsewhere on the continent, and providing a reasoned explanation for its particular shape and scale. That kind of response would be convincing. It would close the question. The problem is that this level of engagement has not consistently been offered. The questions about specific large-scale formations have, in several documented cases, been met with general statements that do not directly address the specific details being raised. That pattern, repeated across multiple instances and multiple sources, is itself worth noting. There is also the matter of location. This is a separate issue from the question of explanation, but it is connected to it. Some of the most discussed and most visually striking images from Antarctica come from regions of the continent that are not regularly accessible to independent researchers. Not all parts of Antarctica are equally visited or equally studied. The continent is vast, and the research stations that operate there are concentrated in specific areas, primarily coastal zones, and a small number of inland sites. Large portions of the interior, and certain specific regions that have drawn attention in satellite imagery, are rarely if ever visited by researchers who operate outside government or institutionally affiliated programs. That detail matters for a specific reason. The teams that conduct field work in the more restricted or remote areas of Antarctica are typically connected to national research programs, some of which have military or intelligence affiliations. This is not unusual for polar science. The logistics of operating in such an extreme environment require the kind of infrastructure and support that often involves governmental and sometimes defense-related organizations. The United States Antarctic Program, for example, is managed through the National Science Foundation but relies heavily on military logistics support for transportation and supply operations. Similar arrangements exist for other national programs. None of that is inherently suspicious. It is simply the practical reality of working in one of the most difficult environments on Earth. But it does mean something for the question of independent verification. When a specific region of Antarctica is primarily accessed through programs that operate under governmental or institutional control, and when that region is the source of images that have raised unresolved questions, the pathway for independent examination of that region is genuinely narrow. An independent researcher, someone not affiliated with an official program, not supported by governmental funding, not operating within the structure of an established national Antarctic mission, would face significant barriers to visiting that location and conducting their own examination. Those barriers are logistical, financial, and regulatory. They are not necessarily placed there to prevent scrutiny, but their effect, regardless of intent, is that scrutiny is limited. At first, that might seem like a minor point. Antarctica is remote. Of course, it is difficult to access independently. That is true of many places on Earth that do not raise any particular questions. But this detail becomes more significant when it is placed alongside the other observations already noted. If the formations in question were in an easily accessible location, independent researchers could visit them, examine them directly, and confirm or challenge the official explanations through first-hand observation. That process, direct examination, independent confirmation, is how scientific claims are typically validated. The fact that it is genuinely difficult to perform that validation in this specific context does not prove anything, but it does mean that the official explanation is harder to independently confirm than it would be for most other scientific claims about most other places. This is not a small distinction. In almost every area of modern science, the principle of independent replication is foundational. A result that cannot be independently verified is treated with caution, regardless of the credibility of the institution that produced it. That principle exists for a good reason. Even the most careful and well-intentioned researchers make errors. Instruments malfunction. Interpretations are influenced by assumptions. Data can be processed in ways that introduce biases that are not immediately visible. The correction for all of those possibilities is independent examination, someone else, working from the same evidence or from the same location, arriving at the same conclusion. When that process is limited, the confidence one can reasonably place in the original conclusion is also limited. Antarctica, due to its remoteness and its governance structure, does not easily allow for that kind of independent confirmation. That is partly a practical matter and partly a structural one. The Antarctic Treaty System, while designed to promote scientific cooperation, also creates a framework in which access is controlled and coordinated through national programs. Researchers who work outside that framework have very limited options. They cannot simply travel to a specific location on the continent and conduct their own examination. The process of gaining access involves institutional affiliations, formal applications, logistical dependencies on national programs, and in some cases explicit authorization for specific areas. The result is that the community of people who have directly examined any given part of Antarctica is small, and that community is largely drawn from within the same institutional structures that have already provided the official explanations. Some people would argue that this is not a problem, that the researchers working within these programs are qualified, dedicated scientists whose findings should be trusted. And in general terms, That argument has merit. The majority of Antarctic research is conducted by people with genuine expertise and legitimate scientific motivations. But trust, in the context of open scientific inquiry, is not meant to replace verification. It is meant to coexist with it. The expectation in science is not that you simply trust competent researchers. It is that competent researchers publish their methods, share their data, and allow others to check their work. In Antarctic research, the second and third parts of that process are more difficult than they should be, not because of any particular failure of integrity, but because of the structural realities of how the continent is accessed and governed. And this is where the explanation becomes difficult. The official position says that the unusual formations in Antarctic imagery are the result of known natural processes. That may well be correct, but when the specific formations in question are large enough that the standard explanations require additional examination, when the regions where those formations appear are not easily accessible to independent researchers, and when requests for specific analysis have consistently been met with general responses, the explanation, whatever its actual accuracy, has not been presented in a way that allows it to be fully evaluated. That is a problem not necessarily with the conclusion, but with the process. There's one more dimension to this that deserves attention. In science, when a finding cannot be independently verified, the standard response is not to dismiss the questions being asked. It is to provide more detailed and more accessible information. If an official institution wants to put questions to rest, the most effective way to do that is to engage specifically with the specific evidence being questioned. That means addressing particular images, particular coordinates, particular formations, not simply restating that natural explanations exist. That level of engagement has been noticeably absent from most official responses to the questions raised about Antarctic satellite imagery. And that absence is itself a piece of information, even if its meaning is unclear. So the first doubt is a simple and precise one. The geological explanation is real, but it does not always fit the scale and consistency of what has been observed. The regions in question are not easily accessible to anyone outside official programs. Independent verification, the standard mechanism by which scientific claims are confirmed, is genuinely limited in this context, and the responses given to specific questions have tended toward the general rather than the particular. None of that proves anything, but it does mean that the situation is not as fully resolved as the official position suggests. The explanation covers a great deal. It does not cover everything, and for the parts it does not clearly cover, the difficulty of independent examination means the gap remains open. That does not fully make sense for a subject that is supposed to be straightforwardly understood. To understand why certain photographs of Antarctica attract the level of attention they do, it helps to step back from the images themselves for a moment. The questions surrounding those images do not exist in isolation. They exist within a broader context, a history of how Antarctica came to be governed, who was involved in its early exploration, and what took place on the continent in the years before the international agreements that now define it were established. That context does not answer the questions raised by the photographs, but it does provide a background against which those questions take on a slightly different character. And some of that background contains details that are, even on their own terms, worth examining carefully. Antarctica was not always the internationally governed scientific zone it is today. For most of human history, it was simply unknown. The existence of a southern continent had been theorized for centuries, but the first confirmed sightings of the Antarctic coastline did not occur until the early 19th century. Exploration followed slowly and at great cost. The early expeditions of the late 1800s and early 1900s, many of which are well documented in historical records, were grueling undertakings that pushed human endurance to its limits. The continent resisted easy exploration. Its weather, its remoteness, and the sheer scale of its ice made systematic investigation extremely difficult. For a long time, what was known about Antarctica was fragmentary and incomplete. By the mid-20th century, the geopolitical landscape had changed considerably. The Second World War had ended. The Cold War was beginning to take shape, and several nations were paying close attention to territories that had previously been considered too remote to matter strategically. Antarctica was among them. Multiple countries had overlapping territorial claims on the continent, claims that were disputed, unrecognized by rivals, and in some cases directly conflicting with one another. The question of who controlled Antarctica, or who might eventually control it, was not purely academic. The continent's resources, its strategic position, and its potential military value were all factors being weighed by the major powers of the time. That is the environment in which the early large-scale military expeditions to Antarctica took place. The Antarctic Treaty, signed in December 1959, was the eventual resolution to that tension, at least on paper. 12 nations signed the original agreement: Argentina, Australia, Belgium, Chile, France, Japan, New Zealand, Norway, South Africa, the Soviet Union, the United Kingdom, and the United States. The treaty established Antarctica as a zone dedicated to peaceful scientific research. It suspended all existing territorial claims and prohibited new ones. It banned military operations, nuclear testing, and the disposal of radioactive waste on the continent. It also included provisions for the inspection of any facility on the continent by any signatory nation, in the interest of transparency. Over the following decades, more countries joined. Today, the treaty has over 50 signatories, making it one of the more enduring examples of international scientific cooperation. On the surface, that story is a clean and positive one. A remote and scientifically valuable continent preserved from militarization and territorial dispute, open to shared research for the benefit of all nations. That framing is largely accurate, and it should not be dismissed. The Antarctic Treaty has, by most assessments, functioned reasonably well as an instrument of international cooperation. But a few details from the period before the treaty was signed are worth examining more closely, because they add a layer of context that the treaty's clean narrative tends to obscure. Before the agreement was in place, and during the years immediately following the Second World War, several nations conducted operations in Antarctica that were not straightforwardly scientific. They were military in scale, military in organization, and in some cases explicitly military in their stated objectives. The most significant of these, at least in terms of the resources involved, was a United States operation known as Operation High Jump. It was launched in 1946 and continued into early 1947, and when the details of that operation are examined carefully, they raise questions that have never been fully resolved. Operation High Jump was not a small expedition. It was, by the standards of Antarctic exploration, enormous. The operation involved approximately 4,700 military personnel. It deployed 13 ships, including an aircraft carrier, the USS Philippine Sea, along with destroyers, submarines, and support vessels. It carried over 24 aircraft of various types. The commander of the operation was Rear Admiral Richard Byrd, an experienced polar explorer who had led previous expeditions to Antarctica. But the overall organizational structure was firmly military. The scale of the resources deployed was, even at the time, striking. Nothing like it had been assembled for Antarctic exploration before, and very little since has matched it in terms of sheer logistical commitment. The stated purpose of Operation High Jump was scientific research and military training. Specifically, the operation was described as an exercise to train personnel and test equipment under extreme polar conditions, while simultaneously conducting aerial surveys and gathering scientific data about the continent. Those are legitimate objectives. Antarctica is a useful environment for testing cold-weather military capabilities, and aerial survey was genuinely needed at the time. Large portions of the continent had never been photographed from the air. If the operation had been a modest undertaking, those explanations would be easy to accept without further examination. But this is where the scale becomes difficult to set aside. Nearly 5,000 personnel, an aircraft carrier, multiple submarines, dozens of aircraft. That is not the logistical profile of a training exercise combined with a scientific survey. Military training operations of that era, even large ones, did not typically require aircraft carriers operating in Antarctic waters. Scientific survey missions did not require submarines. The gap between the stated purpose and the resources committed to achieving it is wide enough that it was noted at the time, not just by outside observers, but by people within the research and policy communities who were paying attention to what the United States was deploying and why. Some researchers and historians who have examined the operation since then have described the stated objectives as insufficient to explain the scale. That assessment is not fringe speculation. It appears in academic and historical analyses of the operation. There's also the matter of how the operation ended. Operation High Jump was originally planned to last between 6 and 8 months. It ended after roughly 2 months. The official reasons given for the early conclusion referenced weather conditions and the approaching end of the Antarctic summer season. Those are real factors. Antarctic conditions in autumn become significantly more dangerous for naval operations, and the window for safe activity in those waters is genuinely limited. Weather-based curtailment of polar expeditions is not unusual, so the early departure, taken on its own, might not seem significant. But the timeline does not fully match the original planning. If weather and seasonal limitations were anticipated obstacles, and they would have been, given that every aspect of the operation was planned well in advance by experienced polar commanders, then the original 6 to 8 month timeline was presumably set with those constraints in mind. An operation of that scale, with that level of planning, would not have been given an optimistic timeline without accounting for the realities of Antarctic weather. If the early departure was simply due to expected seasonal conditions, the question is why the original timeline was so much longer than what conditions would realistically allow. That discrepancy has not been clearly addressed in the official record. Beyond the timeline, there are accounts from personnel who participated in the operation that contain details which do not fit neatly into the narrative of a routine training and survey mission. Some of these accounts were given informally, in interviews or personal records rather than in official reports. They describe aspects of the experience, things observed, areas visited, circumstances encountered, in ways that are vague enough to be interpreted in multiple directions, but specific enough to suggest that something occurred during the operation that was not fully captured in the official documentation. These accounts are difficult to evaluate. They are often second-hand, they lack precise detail, and they exist in a context where personal memory is unreliable and where the passage of decades introduces further distortion. None of them constitute evidence of anything specific, but they contribute to a picture that is slightly more complicated than the official record presents. It is important to be precise about what is and is not being suggested here. Operation High Jump was a real military operation, and its basic facts are documented. The anomalies in its scale and timeline are real anomalies. They are documented discrepancies between stated purposes and deployed resources, and between planned duration and actual duration. These are not invented contradictions. They are details that appear in the historical record and that have not been fully accounted for in the official narrative. Whether those discrepancies point to something specific, or whether they simply reflect the overplanning and under-execution that characterize many large military operations, is a question that cannot be answered definitively from the available evidence. What can be said is that Operation High Jump took place in the years just before Antarctica became subject to international treaty governance, a governance structure that, among other things, placed formal restrictions on military activity on the continent. The timing of that transition from a period of large-scale military operations to a period of internationally governed scientific access is a matter of historical record. Whether the treaty was partly a response to what those early operations discovered, or whether it was simply the product of Cold War geopolitical calculation, is not something the historical record makes entirely clear. Both explanations are possible. The official account favors the geopolitical interpretation, but the geopolitical interpretation does not fully explain why operations of the scale of High Jump were considered necessary in the first place. This is background context. It does not change the photographs or the questions around them. It does not prove anything about what may or may not exist beneath the Antarctic ice, but it does establish something useful. Antarctica has a history that includes military operations at unusual scale, a treaty that emerged from that period and now governs access to the continent, and a pattern of restricted information that predates the current era of satellite imagery by several decades. None of that adds up to a conclusion, but it does mean that the questions being asked today about Antarctica are not entirely new questions. They are, in some ways, a continuation of questions that have been present since the earliest large-scale engagement with the continent. Questions about what was found there, what was done with that information, and why the gap between the official record and the full story has never quite closed. One of the more consistently discussed inconsistencies surrounding Antarctica does not come from a remote research station or a classified government file. It comes from a tool that millions of people use casually on their personal computers and phones, often without giving it much thought. Google Earth. It is a platform most people associate with looking up their home address, planning travel routes, or satisfying idle curiosity about distant places. It is not typically thought of as a source of unresolved questions, but for a specific and recurring set of observations about Antarctica, it has become exactly that. The basic observation is straightforward. Over a period of years, users exploring the satellite view of Antarctica on Google Earth have identified specific areas where the imagery appears noticeably degraded. Not uniformly degraded. Not the kind of general reduction in quality that one might expect across an entire polar region, but selectively degraded. Certain locations show blurring that is abrupt and localized. Specific patches of the continent appear pixelated in ways that look different from the surrounding imagery. Some areas show a visual texture that suggests the image has been processed differently from the regions immediately adjacent to it. These are not subtle differences that require technical expertise to notice. They are visible to any ordinary person looking at the map with reasonable attention. Google has provided explanations for image quality issues in polar regions, and those explanations are technically grounded. Photographing the polar regions from space presents genuine challenges that do not apply in the same way to other parts of the world. Satellites in low Earth orbit pass over polar regions at angles that differ from their typical passes over lower latitudes. The geometry of coverage is different, which means that the same location may be captured from different angles across different passes, making it harder to produce a consistent composite image. The lighting conditions at high latitudes also present difficulties. For extended periods, Antarctica experiences either continuous daylight or continuous darkness. During the summer months, when the sun is always above the horizon, the angle of light across the surface is consistently low, which creates long shadows, high contrast, and reflective glare that complicates image processing. These are real technical challenges, and they affect the quality of polar satellite imagery in ways that are well understood by the people who work with that data. Image stitching is another factor that Google and other mapping platforms regularly cite. The satellite images that make up a composite map of any large region are not taken simultaneously. They are captured at different times, by different satellites, under different conditions, and then assembled into a seamless whole through software processing. That stitching process can introduce visible seams, resolution inconsistencies, and color mismatches, particularly in regions where the underlying surface is visually uniform, like a large expanse of white ice. Antarctica presents almost the most challenging possible conditions for image stitching. The visual uniformity of the surface makes it harder for stitching algorithms to align images accurately, and the result can be patches of inconsistent quality that have nothing to do with deliberate intervention and everything to do with the limits of the technology. At first, those explanations seem sufficient. They are coherent. They are grounded in real technical processes, and they account for image degradation in polar regions in a general way. But this is where the specific pattern of what has been observed begins to create difficulty for the general explanation. The problem is not that blurring and pixelation exist in Antarctic satellite imagery. The problem is where they exist and where they do not. Not all of Antarctica appears in degraded quality on Google Earth. Large portions of the continent are rendered in reasonably sharp detail. Coastal areas near research stations, the Antarctic Peninsula, and various mapped regions of the continent are visible with a level of clarity that allows surface features to be identified without difficulty. The resolution in these areas, while not always perfect, is consistent with what one would expect from a modern satellite mapping platform covering a remote and technically challenging location. So the technical obstacles to imaging Antarctica clearly are real, but not absolute. They do not prevent clear imaging across the entire continent. Clear images exist for many parts of it. The areas where blurring and degradation appear selectively are, in a number of documented cases, inland locations, regions away from the known research stations, areas that do not correspond to any particular coastal geography or any obvious technical reason for differential image processing. Some observers have mapped the coordinates of these degraded zones and noted that they do not consistently align with areas where the technical factors cited by Google, satellite coverage gaps, stitching difficulties, lighting conditions, would be most severe. The degradation does not follow the pattern that the technical explanation would predict. It appears, in some cases, to be concentrated in specific inland locations in a way that is not fully accounted for by the general technical narrative. That is the inconsistency, and it is a specific one. It is worth being careful here about the difference between two types of image degradation. One type is the natural result of technical limitations, uneven coverage, stitching errors, lighting distortion. This type tends to be distributed across regions in a way that reflects the underlying technical causes. It appears more often at extreme latitudes, in areas with poor coverage geometry, in regions where image stitching is particularly difficult. It does not follow the boundaries of specific locations with any particular precision. The other type is selective degradation, blurring or pixelation that appears to be applied to a specific area rather than distributed across a region based on technical conditions. That second type has a different visual signature. It tends to appear as a sharp transition from clear imagery to degraded imagery, sometimes in a way that follows what appear to be deliberate boundaries rather than natural variation in image quality. Some observers who have examined the Antarctic imagery on Google Earth in detail have argued that certain degraded zones show characteristics more consistent with the second type than the first. The transition from clear to blurred is too abrupt. The boundaries of the degraded zone are too defined. The area affected is too specific relative to the surrounding region to be fully explained by general technical factors. Others disagree, arguing that the visual complexity of satellite image processing makes it easy to misidentify natural artifacts as deliberate intervention. Both positions are reasonable, and neither can be fully confirmed without access to the raw data and the processing history behind the images. That data is not publicly available in the detail that would be needed to resolve the question. And this is where another layer of inconsistency enters the picture. When users identify and flag these areas publicly, on mapping forums, social media platforms, or discussion communities, the responses that follow tend to arrive quickly and tend to follow a consistent pattern. The technical explanations are repeated. The observations are attributed to misunderstanding of how satellite imagery works. And in many cases, the people raising the questions are categorized, often within the first few responses, as conspiracy theorists. That categorization is applied broadly to a wide range of people asking a wide range of questions, regardless of the specific nature or quality of the observations being made. That categorization might, in many individual cases, be entirely fair. There's a great deal of genuinely unfounded speculation about Antarctica circulating online. Claims that are easily disproven, theories built on misidentified images, and assertions that have no evidentiary basis are common in this space. Applying skepticism to claims about Antarctica is reasonable and appropriate, but there's a difference between skepticism and dismissal. Skepticism involves examining the specific claim being made and evaluating whether the evidence supports it. Dismissal involves labeling the person making the claim and moving past the specific observation without engaging with it. What tends to happen in many of these online discussions is the second thing, not the first. The label is applied, and the specific visual observation, the coordinates, the characteristics of the blurring, the pattern of where the degradation appears, is not examined in detail. Labeling an observation does not actually address it. That is a simple point, but it is worth stating plainly. If a specific location on Google Earth shows imagery that appears selectively degraded in a way that does not match the surrounding area, calling the person who noticed it a conspiracy theorist does not explain why the degradation is there. It redirects the conversation away from the specific observation and toward the credibility of the observer. Those are two different things. The credibility of the observer is relevant to how much initial weight one gives to the claim, but it does not determine whether the observation itself is accurate or whether it has an adequate explanation. There is also the question of how the broader pattern fits together. Individual cases of blurred imagery might each have an individual technical explanation, but when the same pattern selective inland degradation, abrupt transitions, specific coordinates that recur in multiple independent observations, appears across a number of separate instances. The cumulative picture begins to require a more systematic explanation than any single technical factor can provide. Either there is a consistent technical reason why those specific inland areas consistently appear in lower resolution than surrounding regions, or there is something else determining the pattern. The technical explanations that have been offered address the general case of polar imaging difficulty. They do not address the specific pattern of which locations appear degraded and which do not. It is also worth noting that this is not a new observation. Users have been flagging specific degraded zones in Antarctic satellite imagery for well over a decade. The observations have been made independently by different people, using different versions of the same mapping tools across different years. The consistency of the observations, the fact that the same locations recur in reports from different sources at different times, suggests that the degradation is not random noise. Random technical artifacts do not reliably reproduce in the same specific locations across different satellite passes and different processing periods. If the same inland area appears degraded in imagery from multiple different time periods, that pattern requires an explanation that goes beyond random imaging error. The question of why certain inland areas of Antarctica appear consistently obscured in publicly available satellite imagery remains technically unanswered in any specific, location-by-location way. General technical explanations exist, and they are not without merit, but they do not account for the selectivity of the pattern or the consistency with which specific locations recur across independent observations. Whether that pattern reflects a limitation of the technology, a decision made at the level of data processing, or something else entirely, is not something that can be determined from the outside. What can be said is that the pattern exists, that it has been noted repeatedly by a wide range of observers, and that the responses offered so far have not engaged with the specifics in a way that fully resolves it. The inconsistency remains present, and it does not fully make sense within the framework of the explanations currently available. In 2016, a set of images began circulating across news websites, social media platforms, and independent research communities that attracted a different kind of attention from previous Antarctic photographs. Earlier images had required some effort to interpret. They showed shapes beneath the ice, linear features, or blurred zones that needed explanation. These new images were more immediately striking. They showed, rising above the surface of the Antarctic ice, a large formation with a shape that was difficult to look at without noticing its symmetry. 4 faces, defined edges, a structure that narrowed as it rose and came to a point at the top. To many people seeing it for the first time, the resemblance to a pyramid was not something that needed to be argued. It was simply visible. The images spread quickly. They were picked up by mainstream news outlets, not just by fringe websites or independent commentary channels. Publications that do not typically cover speculative topics ran pieces on the formation, usually framed around the question of what it was and whether it had a natural explanation. The level of public interest was significant. For a brief period, the Antarctic Pyramid, as it came to be called in popular discussion, was one of the more widely discussed geographical observations on the Internet. The attention it received was partly due to the visual clarity of the photographs. The shape was prominent, the symmetry was easy to see, and the contrast between the dark rock faces and the surrounding white ice made the structure stand out sharply. Scientists responded to the attention relatively quickly. Geologists who study polar terrain identified the formation as a nunatak, a mountain peak that protrudes through the surface of an ice sheet. Nunataks are common in Antarctica. The continent has thousands of them, ranging from small rocky outcroppings barely visible above the ice to large peaks rising hundreds of meters. The specific formation in question was located in the Ellsworth mountain range in West Antarctica, a region with a number of exposed peaks of varying shapes and sizes. The identification itself was not controversial among researchers. The formation is a mountain. It has a geological history. It is made of rock that has been present in that location for a very long time. That much is not in question. The geological explanation for how a mountain can develop a pyramidal shape is called freeze-thaw weathering, and it is also a well-established process. It works like this. Water enters cracks in exposed rock through rainfall, snowmelt, or condensation. When temperatures drop, that water freezes. As it freezes, it expands. The expansion exerts pressure on the surrounding rock from within the crack. Over time, repeated cycles of freezing and thawing gradually widen and deepen those cracks, breaking off sections of rock along the fracture lines. When this process operates consistently on multiple faces of an exposed mountain peak, it can progressively shape the rock into angular faces that meet at defined edges. The result, after a very long period of this kind of erosion, can be a mountain with a roughly pyramidal profile. The process is called glacial horn formation, and examples of it exist in mountain ranges around the world. The Matterhorn in the Alps is one of the most frequently cited examples, a peak whose strikingly angular shape is the product of the same kind of glacial and freeze-thaw erosion process. So the explanation is real. It is not invented for the occasion. Pyramidal mountain shapes occur in nature. They have a documented geological cause, and they have been studied and described in detail by researchers who work with mountain and glacial terrain. When geologists pointed to the Ellsworth Formation and said it was a natural pyramidal peak, produced by known geological processes, they were drawing on a body of knowledge that is genuinely sound. That should be stated clearly, because the explanation is not weak in its fundamentals. The process it describes is accurate, and the category of formation it identifies, a glacial horn, is real and well documented. But this is where the explanation starts to weaken for some observers, and the reason is specific rather than general. The issue is not with the process being described. It is with how well the visual evidence of this particular formation matches what that process typically produces. Glacial horn formation, even when it operates with remarkable consistency on a mountain peak, tends to produce results that show the influence of variable conditions over time. Different faces of the mountain erode at different rates, depending on their orientation, the direction of prevailing winds, the angle of sunlight, and the specific composition of the rock on each face. The result is that naturally formed pyramidal peaks, even very symmetrical-looking ones like the Matterhorn, show visible asymmetry when examined closely. One face is steeper than another. The edges between faces are irregular. Some faces show more weathering, more fracturing, more evidence of the erosion process than others. The overall shape may be approximately pyramidal, but the details are uneven, as one would expect from a natural process operating over a very long time under variable conditions. The Antarctic formation attracted attention precisely because its four faces appeared unusually even. The symmetry that made the photographs so striking was not just the general pyramidal shape. It was the regularity of the individual faces and the consistency of the edges between them. To observers comparing it to other naturally formed pyramidal peaks, including well-studied examples like the Matterhorn, the evenness seemed unusual. Natural examples typically show more variation. The faces of a glacially eroded peak do not usually look as though they were produced by the same process operating at the same rate on all sides simultaneously. And yet the Antarctic formation, in the photographs that circulated widely, appeared to show a degree of facial regularity that some observers found difficult to attribute entirely to natural variation. Some geologists acknowledged this observation. They did not dismiss it entirely. A few noted that the specific conditions in Antarctica, the particular composition of the rock, the patterns of wind and ice movement in that region, the long-term glacial history of the Ellsworth Range, could produce a more symmetrical result than typical examples in other mountain ranges. That is a reasonable argument. Geological conditions vary from location to location, and it is not impossible that the specific factors present at this site produced an unusually regular outcome. But the argument was generally offered in broad terms rather than supported by a detailed comparative analysis of this formation against other glacial horns in comparable conditions. The claim that local conditions explain the unusual symmetry was stated, but not fully demonstrated. And for many observers, a stated explanation without supporting detail occupies a different position than a demonstrated one. Others among the researchers who commented publicly were less specific still. They confirmed the Nunatak identification, confirmed that pyramidal peaks occur naturally, and pointed to the general geological framework without engaging closely with the specific visual characteristics that had drawn the most attention. This pattern, confirming the category without addressing the specific details, is one that has appeared in other official responses to Antarctic observations. It is not necessarily evasive. Researchers are often commenting outside their precise area of specialization, and detailed analysis of a specific formation requires access to data and time that an informal public response does not provide. But it does mean that the questions raised by the specific visual evidence were not fully addressed, even when the general explanation was sound. There is also the matter of ground-level investigation. The most definitive way to resolve questions about a geological formation is to examine it directly. Field researchers who can access the site, take measurements, collect samples, analyze the rock composition and structure, and compare the findings to known geological models would be in a position to confirm or challenge the natural explanation with much greater precision than satellite imagery allows. For most natural formations that attract scientific interest, field investigation follows fairly naturally from the observation. It is how geology works. Remote observation suggests a hypothesis, and field investigation tests it. But in this case, no widely published independent ground survey of the specific formation has emerged. The discussion largely settled into the official explanation, nunatak, glacial horn, natural process, without the kind of detailed field-based follow-up that would normally accompany a significant geological observation. That absence does not prove anything. Antarctica is genuinely difficult to access, and field research requires resources and planning that take time to arrange. The formation is in a remote part of the continent, not adjacent to any existing research station. The logistical challenges of conducting a ground survey there are real. It is entirely possible that researchers with relevant expertise have visited the site without the results being widely publicized, or that such a visit is planned and has simply not yet occurred. All of those possibilities exist. But the absence of a published ground survey does mean that the most direct method of resolving the visual questions, physical examination of the formation, has not been documented in the publicly available record. And without that documentation, the discussion has no definitive endpoint. What remained, after the initial wave of media coverage and scientific response, was a situation where two things were simultaneously true. The official explanation was scientifically coherent and drew on genuine geological knowledge, and the specific visual evidence, the unusual symmetry of the four faces, the regularity of the edges, the consistency of the proportions across a formation of significant scale, had not been fully accounted for within that explanation. Both of those things were true at the same time. That is not a comfortable position. It does not resolve into a clean answer in either direction. Some believe the explanation is complete, and that the visual impression of unusual symmetry is simply a product of the specific photographic angle and lighting conditions under which the most widely circulated images were taken. Others disagree, arguing that the symmetry is visible across multiple images taken from different angles and under different conditions, and that the photographic explanation does not fully account for what is observed. Neither position has been definitively settled. The formation sits in a remote part of Antarctica, visible in satellite imagery, identified by name in geological records, and yet still the subject of unresolved visual questions that the available explanations have not entirely answered. The broader significance of this particular case is not in what the formation definitely is or is not. It is in what the response to it reveals about how questions concerning Antarctica tend to be handled. The explanation was offered quickly. It was categorically sound. It was repeated consistently across multiple sources, and yet it left specific details unaddressed, details that were visible in the photographs and that a more thorough engagement with the evidence would need to account for. The pattern is a familiar one by this point. A general explanation is provided. The specific observation is absorbed into that explanation without a precise fit being demonstrated. The discussion moves on, and the visual evidence, for many people who examined it carefully, remains not quite fully resolved. That is where the situation stands. The explanation exists. The questions around it exist, and the gap between the two has not been clearly closed. What makes the photographs of Antarctica worth continued and careful attention is not any single image taken in isolation. Individual images can be misidentified. Individual observations can be the product of misunderstanding, technical error, or simple wishful thinking. Any one photograph, no matter how unusual it appears, carries limited weight on its own. A single blurred zone in a satellite map could be a stitching error. A single angular formation could be a nunatak photographed under unusual lighting. A single general response from an official source could simply reflect the time constraints of a busy researcher rather than any deliberate avoidance. Taken individually, each of these things has a plausible, innocent explanation. That is an important starting point, and it should not be abandoned. But the case for continued attention does not rest on any single image or any single observation. It rests on a pattern, and patterns operate differently from individual data points. When similar types of observations appear repeatedly, across different years, drawn from different sources, originating in different locations across the continent, the cumulative picture becomes harder to dismiss through individual explanations. Each piece may have its own explanation, but when the pieces consistently resemble each other, when they cluster around similar locations and similar characteristics, and when the responses to them follow a consistent structure, the pattern itself becomes a subject of investigation. That is where the examination of Antarctic imagery now stands. The pattern has several distinct components. The first is the recurrence of unusual geometric formations across different parts of the continent and across different periods of time. These are not all the same image shared repeatedly. They are independent observations, made by different people using different tools, showing formations in different locations that share similar visual characteristics, shapes that appear too regular, lines that appear too consistent, proportions that do not obviously fit the standard geological explanations. No single one of these observations is definitive, but their recurrence across independent sources means they are not simply the product of one person's misinterpretation being repeated online. The same category of observation keeps appearing, independently, over time. The second component is the pattern of degraded or restricted imagery in specific inland areas. As noted in earlier observations, this is not uniform degradation across the entire continent. It is selective, concentrated in particular locations, appearing with a consistency that means the same coordinates appear in independent reports from different years. Again, any single instance could be explained technically, but when the same locations appear repeatedly in independent reports of unusual imagery quality, the technical explanation needs to account for why those specific locations are consistently affected while surrounding areas are not. That accounting has not been clearly provided. The technical explanation covers polar imagery in general. It does not explain why the pattern of degradation is as geographically specific as observers have reported it to be. The third component is the structure of the official responses. This is perhaps the most consistently noted aspect of the overall pattern, and it is worth examining carefully. When questions about specific Antarctic formations or specific degraded zones are raised, the responses from official and mainstream sources tend to follow a recognizable structure. They begin with a general confirmation that the continent is well studied. They identify the category of phenomenon that the observation probably falls into: wind erosion, nunatak, imaging artifact. They confirm that the category is real and scientifically grounded, and then they move on, without engaging in detail with the specific visual characteristics that made the observation notable in the first place. The category is addressed. The specific case is not. This pattern of response is not unique to Antarctica. It appears in many areas where official institutions address questions from non-specialist audiences. In general communication, it is common to answer the general form of a question rather than its specific details. That tendency is often not deliberate. It reflects the practical realities of communication between specialists and non-specialists. But in the case of Antarctica, the pattern is consistent enough and widespread enough that it has become noticeable as a feature of the overall situation rather than an incidental characteristic of individual responses. When the same structure, general category confirmed, specific detail unaddressed, appears across responses from multiple institutions, multiple researchers, and multiple time periods, it begins to look less like a communication style and more like a policy. Some researchers who work specifically in the field of remote sensing imagery, the analysis of data captured by satellites and aerial platforms, have noted something that adds another dimension to the pattern. Their observation is about comparative treatment. Antarctica is not the only remote and largely uninhabited region on Earth. There are other vast, sparsely populated territories that present similar challenges for satellite imaging. The interior of Siberia, the deep Saharan desert, the remote reaches of the Amazon basin, and large sections of the world's ocean floors. These regions are all photographed from space. They all present technical challenges for imaging. They all contain areas that are difficult to photograph consistently or clearly. But observers who have examined publicly available satellite databases have noted that the pattern of selective blurring, the frequency of imagery inconsistencies, and the concentration of rendering anomalies in specific locations is not equally distributed across all remote regions. Antarctica appears to attract a disproportionate share of these anomalies relative to similarly remote and similarly uninhabited areas. That detail sounds minor at first, until it is examined more closely. If the inconsistencies in Antarctic imagery were purely the product of technical limitations inherent to polar satellite photography, one would expect the Arctic to show similar patterns, since it presents many of the same technical challenges. The Arctic is also a polar region. It also experiences extended periods of low-angle sunlight. It also has large expanses of reflective ice. It also lacks the human infrastructure that makes urban regions easier to photograph consistently. And yet reports of the same pattern of selective inland degradation, specific recurring blurred zones, and anomalous rendering in particular coordinates are significantly less common for the Arctic than for Antarctica. That asymmetry does not have a straightforward technical explanation. Technical limitations should produce similar patterns in similar technical environments. The fact that they appear to produce a more concentrated pattern in one polar region than the other raises a question that the general technical explanation does not address. This is where the possibility arises that the inconsistencies in Antarctic imagery are not purely the result of technical limitations, but may also reflect decisions made about how certain areas of the continent are rendered in public databases. This is not a claim that anything specific is being hidden. It is an observation that the pattern of what is and is not clearly visible in public satellite imagery of Antarctica does not fully match what purely technical factors would predict. Something may be influencing which areas are rendered clearly and which are not. What that something is, whether it reflects deliberate management of public visibility, institutional decisions about data release, agreements between governments and mapping platforms, or simply an uneven distribution of technical resources applied to different parts of the continent, is not something that can be determined from the outside. But the pattern itself is present and has been noted by people with relevant technical expertise, not just by casual observers. There is also a fourth component to the overall pattern, and it involves how people who investigate these topics are treated within public discourse. This is a separate issue from the quality of the evidence, but it is relevant to understanding the full shape of the situation. Researchers, journalists, and independent observers who raise questions about Antarctic imagery or Antarctic history are frequently categorized quickly and negatively before their specific work is examined. The label of conspiracy theorist is applied broadly and early in the response process. This happens in comment sections, in media coverage, and sometimes in responses from institutional sources. The categorization is used as a reason to stop engaging with the substance of the observation rather than as a conclusion reached after examining it. Some believe this response is entirely justified. There is, as has been acknowledged, a great deal of genuinely unfounded and irresponsible speculation about Antarctica. The space of public discussion about the continent includes many claims that are easily disproven, many theories that rely on selective reading of evidence, and many assertions that have no basis in anything verifiable. Applying strong skepticism to claims about Antarctica is reasonable. The concern is not with skepticism itself. The concern is with the consistency with which the dismissal precedes the examination. When a specific, detailed, evidence-based observation is treated in the same way as an unfounded theory, simply because both come from outside the institutional framework, that consistency is itself a pattern worth noting. In most areas of intellectual inquiry, the appropriate response to a specific observation is specific engagement, an observation that includes coordinates, visual characteristics, comparative data, and a clear articulation of what is and is not being claimed deserves a response that engages with those specifics. If the observation is wrong, the specific engagement will show why. If it is right, the specific engagement will reveal that too. What specific engagement does not permit is the comfortable middle position of neither confirming nor addressing the observation, the position that is currently occupied by most of the official discourse around Antarctic imagery. That middle position allows the appearance of having responded without actually doing so, and it allows questions to remain open indefinitely without the responsibility of closing them through genuine examination. The pattern, then, is not one thing. It is several things occurring together, consistently, over a period of years. Recurring geometric observations from independent sources. Selective imagery degradation that does not fully follow the distribution predicted by technical explanations. Comparative anomalies between Antarctica and other similarly remote regions. Official responses that address categories rather than specifics. And a discourse environment where questioning is frequently dismissed before it is examined. None of these components, individually, constitutes a significant finding, but together, as a consistent and recurring pattern, they describe a situation that is not fully explained by any of the individual explanations currently on offer. What a pattern of this kind calls for is not a dramatic conclusion. It calls for more specific engagement. It calls for the kind of response that addresses individual observations in individual detail, particular coordinates explained with particular data, specific formations analyzed against comparable examples, the distribution of imagery anomalies accounted for in a way that addresses the comparative question. Whether that level of engagement would resolve the questions or deepen them is not something that can be predicted in advance, but the absence of it is itself part of the pattern, and the pattern, considered as a whole, does not fully make sense within the framework of what has been officially offered so far. The observations keep returning, the responses keep following the same structure, and the gap between specific question and specific answer remains consistently present, year after year, across source after source, without narrowing in any meaningful way. The questions surrounding Antarctic photographs are easier to set aside when they are viewed as an isolated phenomenon, a collection of unusual images, some unexplained blurring on a mapping platform, a pyramid-shaped mountain that attracted brief media attention. Viewed that way, the whole subject can be filed under the category of internet curiosity and left there without much difficulty. But the questions do not stay isolated. When the context around them is examined more carefully, they connect to a broader and more substantive set of issues about how information relating to Antarctica is accessed, controlled, and in some cases, simply not made available. That broader context does not make the photographs more or less unusual than they are, but it does change the framework within which they sit. The starting point for understanding that broader context is the structure of access to the continent itself. Antarctica is governed by the Antarctic Treaty System, which, as discussed earlier, was designed to promote open scientific cooperation among signatory nations. The treaty includes provisions for transparency and inspection. Any signatory nation is theoretically entitled to inspect any facility on the continent operated by any other signatory. That principle of openness is central to the treaty's stated purpose. But the practical reality of how access to specific areas of the continent is managed does not always reflect that principle consistently. Several countries maintain what are formally designated as restricted zones, areas where access is controlled, limited, or prohibited, even for researchers from other treaty nations who would in principle be entitled to visit. The justifications given for these restricted zones vary. Some are designated as Antarctic Specially Protected Areas, or ASPAs, under the treaty's environmental protocol. The stated purpose of these designations is to protect fragile ecosystems from contamination and disturbance, a legitimate concern given the sensitivity of Antarctic biodiversity and the risk that human activity poses to pristine environments that have evolved in isolation. Environmental protection is a real and valid reason to restrict access to specific areas. The concern is not with the principle. It is with the application. Not all restricted zones are equally explained. Some carry designations that are vague in their stated justification. Others have explanations that are internally inconsistent, citing environmental sensitivity for areas where the primary surface is bare rock or deep ice, with limited biological activity. A few have had their restriction status changed or extended without public explanation. That detail sounds minor at first, until it is examined more closely alongside the pattern of other access limitations already noted. The inconsistency in how restrictions are justified matters because it creates a situation where the same framework, environmental protection, is being applied to areas with very different characteristics. When the same justification covers both a genuinely fragile coastal ecosystem and a remote inland ice field with no apparent biological sensitivity, the justification begins to look less like a specific rationale and more like a general mechanism for controlling access without requiring a detailed explanation in each case. That does not prove anything about what is in those areas, but it does mean that the restriction framework, as currently applied, does not allow outside observers to clearly distinguish between areas that are restricted for the stated environmental reasons and areas that might be restricted for other reasons that are not being stated. Around 2017, a separate category of observation began attracting attention in specialist publications that cover polar affairs and international security. Reports emerged of increased activity in Antarctic regions by nations that had not previously maintained a significant presence on the continent. New research stations were being established. Existing stations were being expanded beyond the scale that their stated research programs appeared to require. Flight paths over certain regions were being altered in ways that were noted by aviation tracking systems. Some nations were deploying infrastructure, communications equipment, logistical support facilities, transportation assets that exceeded what a standard scientific research program would typically need. These developments were reported in specialist journals, policy publications, and in the coverage of a small number of journalists who track polar geopolitics. They received almost no attention in mainstream international media. The nations involved in these expansions included several that have historically maintained limited Antarctic programs, but that are significant players in broader geopolitical terms. The scale and pace of certain expansions raised questions among polar policy analysts about whether the activities being conducted were purely scientific in nature. This is not a straightforward issue. Nations expand their research presence in Antarctica for a wide range of legitimate reasons. Scientific interest in the continent has grown as climate research has become more urgent. Antarctica's ice sheet is central to understanding sea level rise, and the geophysical data available from the continent is increasingly valuable for a range of research fields. Strategic interest in the Southern Ocean, which surrounds Antarctica and is becoming more economically and militarily significant as shipping routes and resource extraction in that region develop, also provides legitimate motivation for expanding national presence. None of that is inherently suspicious, but the scale and pace of certain specific expansions seemed, to analysts who examined them in detail, to go beyond what standard scientific research programs would require. Infrastructure was being built faster than research programs could plausibly use it. Personnel numbers at certain facilities were growing in ways that did not correspond to any announced expansion of scientific activity. Logistical assets were being positioned in patterns more consistent with operational readiness than with the support requirements of a research station. These observations appeared in specialist publications. They were made by analysts with relevant expertise in polar policy and military logistics, and they did not receive the kind of public scrutiny that developments of comparable scale in other regions would typically attract. The relative silence of mainstream media on these developments is itself something that contributes to the broader picture. This is where the explanation becomes difficult. The Antarctic Treaty prohibits military operations on the continent and in principle requires transparency among signatories. If expanded national activities were genuinely military rather than scientific in nature, that would represent a significant breach of the treaty framework that has governed the continent for over 6 decades. The treaty system has mechanisms for addressing such breaches: inspection rights, consultation procedures, diplomatic channels. But those mechanisms operate within the treaty system itself, which means they rely on the cooperation of the nations involved. If a nation chooses to describe military-adjacent infrastructure as scientific, and if the other signatories choose not to formally challenge that description, The treaty's transparency provisions can be rendered ineffective without being formally violated. The gap between what the treaty says and what it can actually enforce is considerable. There is an additional dimension to the broader problem that involves not just access to the physical continent, but access to the academic literature that studies it. Several independent researchers who have attempted to publish detailed analyses of Antarctic satellite imagery, work that identified and documented specific visual anomalies in a structured, methodologically transparent way, have described significant difficulty getting their work into standard academic channels. Some submitted papers to peer-reviewed journals in fields relevant to their work and were told that their methodology was flawed, without receiving the specific methodological critique that would normally accompany such a rejection. Others submitted work and received no response at all, not a rejection with explanation, not a request for revision, simply silence. A small number described being contacted informally and advised that their work was not appropriate for publication in the journals they had approached. These accounts are difficult to evaluate from the outside. Academic publishing is genuinely competitive. Rejection without detailed explanation is not unusual, particularly for work submitted to journals outside the researcher's primary field or for work that challenges established positions. The peer review process has well-documented limitations, including inconsistency in how submissions are evaluated and a tendency to be skeptical of findings that contradict existing consensus. All of that is true, and it means that difficulty in publishing does not, on its own, indicate anything beyond the ordinary challenges of academic communication. Some believe these researchers simply encountered the standard obstacles of working outside mainstream institutional frameworks. Others disagree, pointing to the consistency of the pattern across multiple independent researchers working on similar topics. But this is where it becomes unclear. The difficulty of publishing is a separate issue from the quality of the underlying work. If the methodology of a specific analysis is genuinely flawed, a specific critique of that methodology is the appropriate response. If the work is methodologically sound but the findings are controversial, the peer review process is supposed to evaluate the evidence rather than the controversy. When rejections are given without specific methodological critique, and when that pattern appears across multiple independent researchers working in the same general area, it raises the question of whether something other than methodological evaluation is influencing the publication process. That is not a claim that suppression is occurring in any organized or deliberate sense. It is an observation that the pattern of outcomes is consistent with something influencing access to publication channels in a way that goes beyond ordinary peer review dynamics. The cumulative effect of these observations, restricted zones with inconsistent justifications, expanded national activities that exceed the apparent requirements of stated scientific programs, mainstream media silence on developments that specialists have documented, and publication difficulties for independent researchers, is that the problem of information access around Antarctica is not limited to a few unusual photographs. The photographs are the most visible and most publicly discussed element of a broader pattern of limited transparency. They are the part of the situation that ordinary people can engage with directly, because the images are available and the questions they raise are visually evident. But behind those images, the structure of how information about Antarctica is managed, what is accessible, what is restricted, what is published, what is silenced, points to a situation that is more complex than a collection of misidentified geological formations. None of this is proof of anything specific. Restricted zones have stated justifications. National expansions have stated purposes. Academic rejections have stated reasons. Mainstream media silence on specialist topics is normal and does not require explanation beyond ordinary editorial priorities. Each of these things, individually, operates within the range of what is expected and explicable. But the expanding scope of these access and publication issues, the fact that they appear across multiple dimensions of the same general subject, consistently and over time, suggests that the problem may be significantly larger than a few unusual photographs from a distant continent. The photographs drew attention to something. What they drew attention to, it now appears, sits within a much wider and much less clearly mapped territory, and the boundaries of that territory have not yet been fully established. When an official explanation leaves specific questions unanswered over an extended period of time, Other interpretations tend to emerge to fill the space those unanswered questions create. This is a predictable and understandable human response to incomplete information. It is not unique to Antarctica. It happens wherever the gap between what is visible and what is explained remains open long enough for alternative frameworks to develop. The question is not whether alternative interpretations will appear. They always do. But whether any of them address the specific details that the official account has left unresolved. In the case of Antarctica, several distinct alternative views have emerged over the years. They range considerably in their degree of caution and their basis in available evidence. Some are measured and grounded in specific observations. Others reach further than the evidence supports. But each of them, in its own way, is a response to the same underlying problem, that the standard explanation has not fully closed the questions it was meant to close. The first and most cautious category of alternative interpretation does not require any departure from conventional science or conventional history. It simply proposes that what is being protected in the restricted areas of Antarctica is not something extraordinary in a scientific sense, but something sensitive in a geopolitical or strategic sense. This view is held by a number of researchers and analysts who approach the subject from backgrounds in international relations, resource economics, and security studies, rather than from the more speculative end of the discussion. Their argument is straightforward. Antarctica sits on top of significant natural resources. Geological surveys conducted over several decades have identified substantial deposits of coal, iron ore, and other minerals beneath the ice. More significantly, estimates of offshore hydrocarbon deposits in the Antarctic continental shelf suggest the presence of oil and natural gas reserves that could be economically valuable if extraction technology and political conditions ever made exploitation feasible. The Antarctic Treaty currently prohibits mineral resource extraction, but that prohibition is not permanent and has been the subject of ongoing diplomatic tension. Nations with research presence in Antarctica are, among other things, positioning themselves for whatever future negotiation may eventually occur around those resources. Within this framework, restricted access to certain zones makes straightforward sense. If a nation has conducted surveys that identified a significant mineral or hydrocarbon deposit in a specific location, restricting access to that location, under the cover of environmental protection or safety designation, would prevent other nations from obtaining the same information independently. That is geopolitical competition, not scientific concealment. It requires no unusual assumptions about what is in those areas. It simply requires acknowledging that the stated justification for a restriction and the actual motivation for it are not always the same thing. Some believe this explanation accounts for most of the access limitations around Antarctica without requiring anything more complex. Others point out that this still does not fully explain the specific visual anomalies in the satellite imagery. Resource deposits do not typically produce surface formations that look geometric or structured. So even within this relatively measured interpretation, the explanation is not entirely complete. A second explanation within this same cautious category involves undisclosed military infrastructure. Despite the Antarctic Treaty's prohibition on military operations, several nations maintain facilities on the continent whose full activities are not publicly documented. The treaty allows military personnel and equipment for scientific purposes, a provision that is broad enough to cover a significant range of activities that would not typically be described as purely scientific. If certain restricted zones contain infrastructure that serves military or intelligence functions, communications arrays, monitoring stations, subsurface installations, that would explain both the access restrictions and the interest in keeping certain areas of the imagery less than fully clear. This explanation also does not require extraordinary assumptions. Military and intelligence infrastructure in remote locations is a well-established reality in other parts of the world. The question of whether it exists in Antarctica is not inherently more remarkable than its existence elsewhere, but it is a question that cannot be verified from the outside, which means it remains in the same uncertain space as the other unresolved details. A third possibility that some analysts have raised involves early-stage climate intervention or geoengineering research. Antarctica is a critical node in the global climate system. The stability of its ice sheet directly affects sea levels worldwide. Its influence on ocean circulation patterns is fundamental to how heat is distributed across the planet. If any nation or group of nations were conducting experimental interventions in Antarctic climate systems, testing methods of slowing ice melt, altering local atmospheric conditions, or studying the feasibility of large-scale climate modification, the incentive to restrict independent access to those areas would be considerable. The political and scientific controversy that would surround such activities, if they became publicly known before they were well understood, would be significant. This interpretation is more speculative than the resource and infrastructure explanations, and there is no direct evidence to support it. But it sits within the range of technically conceivable activities that would explain restricted access without requiring a departure from conventional scientific frameworks. These three interpretations, resource protection, military infrastructure, and climate research, share a common characteristic. They are all essentially conventional explanations for unconventional levels of restriction. They do not require revising the standard account of Antarctic history or proposing the existence of anything that falls outside normal scientific categories. They simply propose that the actual motivations behind certain access restrictions are different from the stated motivations, and that those actual motivations involve things that nations have ordinary strategic reasons to keep undisclosed. For many observers, this category of explanation is the most plausible starting point. It accounts for the access patterns without requiring unusual assumptions. But it does not address everything. It does not clearly explain the specific visual characteristics of certain surface formations, and it does not engage with a separate line of observation that some researchers consider independently significant. That separate line involves the historical and cartographic record. Some researchers who have examined the questions around Antarctica from a historical perspective point to a body of evidence suggesting that the continent, or at least portions of its coastline, may have been known to cartographers significantly earlier than the official historical account records. The most frequently discussed piece of this evidence is the Piri-Reis map, a document produced by an Ottoman admiral and cartographer named Piri-Reis in 1513. The map was rediscovered in the early 20th century and has been the subject of considerable scholarly debate since then. A portion of the map appears to show a large southern landmass with a coastline whose outline resembles, in certain respects, the coastline of Antarctica as it would appear without its ice sheet. The resemblance is not perfect, and mainstream historians generally attribute it to coincidence, misinterpretation, or the influence of speculative ancient geographical theories that propose the existence of a southern continent without any actual knowledge of it. Those are reasonable responses, but the debate around the Piri-Reis map has not been fully closed. Some researchers who have examined it in detail argue that certain features of the depicted coastline correspond more closely to the subglacial topography of Antarctica, the shape of the landmass beneath the ice, as mapped by modern sonar surveys, than to the speculative southern continent of ancient geographical theory. If that correspondence is more than coincidental, it implies that whoever contributed to the source material for that portion of the map had access to information about Antarctica's actual geography at a time that predates its official discovery by several centuries, and possibly at a time when the continent's coastline was less obscured by ice than it is today. That implication is significant, and it is one that the mainstream historical account has not fully addressed with the level of specific cartographic analysis that the claim would require. There is also a broader category of pre-ice geological observation that some researchers connect to the cartographic question. Paleoclimatic evidence confirms that Antarctica had a significantly different environment in the distant past, warmer, with liquid water, coastal features, and conditions that supported vegetation and, potentially, other biological activity. The question of when the ice sheet reached its current extent, and whether there were any periods during the transition from ice-free to fully glaciated when parts of the continent's coastline were accessible, is one that the geological record has not answered with perfect precision. The general timeline is established, but the margins of uncertainty within that timeline are wide enough to allow for the possibility of periods of partial accessibility that the standard account does not clearly account for. Some researchers believe those periods are relevant to understanding how knowledge of Antarctica's geography could have existed before its official discovery. Others consider the timeline too remote to be relevant to any documented human history. the disagreement has not been resolved. A third category of alternative view focuses not on history or geopolitics, but on the physics of ice and subglacial geology. The argument here is that large structures existing beneath the Antarctic ice sheet, whether natural geological formations of unusual regularity or something else, could produce surface expressions visible in satellite imagery through the mechanical properties of ice movement. Ice flows. It moves over the landscape beneath it, and as it does, it transmits some of the shape of that landscape to its surface. This process, called isostatic response or glacial surface expression, is documented and understood in general terms. If a subglacial feature has a regular, geometric shape, whether because of unusual geological conditions or for any other reason, the overlying ice could, under certain conditions, preserve some of that regularity in its surface topography. This interpretation does not require the structures to be visible at the surface. It proposes that what is visible at the surface is a transmitted reflection of what lies beneath. That possibility has not been systematically examined in relation to the specific formations that have drawn attention, and the conditions under which surface expression is clear enough to be detected in satellite imagery are not fully established. None of these views are confirmed. Some are considerably more plausible than others, and the distance between the most cautious interpretation and the most speculative one is significant. But what is notable about the full range of alternative views is not any single one of them. It is the fact that so many distinct interpretations have developed, each addressing different aspects of the same set of unresolved observations, and each finding at least some specific detail in the available evidence to anchor itself to. When a single official explanation generates this breadth of alternative response, the range of those alternatives is itself informative. It reflects the size of the space that the official account has left unfilled. People do not develop elaborate alternative frameworks for questions that have been clearly and specifically answered. The variety of interpretation surrounding Antarctica is, in its own way, a measure of how much the standard explanation has left open, and that open space, populated now by a wide range of competing views, continues to sit without a clear resolution available from any direction. After going through the photographs, examining the official responses, tracing the patterns, and considering the range of alternative interpretations, it is reasonable to stop and ask what all of it actually amounts to. That is a fair question. Any investigation that spends considerable time accumulating observations, identifying inconsistencies, and noting unanswered questions eventually reaches a point where the weight of those observations needs to be assessed honestly. Not optimistically, not dismissively, but honestly. And the honest answer, after everything that has been examined here, is that the situation remains uncertain. Not uncertain in a way that points clearly in one direction or another. Uncertain in the more uncomfortable sense, the sense in which multiple things are simultaneously true. None of them fully resolve into a clean conclusion, and the overall picture remains genuinely unclear. That uncertainty is itself worth sitting with for a moment before moving further. In most investigations, uncertainty at the end feels like a failure, like the inquiry did not go far enough or did not find what it was looking for. But uncertainty is sometimes the accurate result. It is the accurate result when the available evidence, genuinely, does not support a definitive conclusion in either direction. Forcing a conclusion where the evidence does not support one is not resolution. It is the appearance of resolution, and the subject of Antarctic imagery and Antarctic access has attracted enough false certainty from enough directions, both from those who dismiss every question and from those who overstate every observation, that adding more false certainty in either direction would not be an improvement. The uncertainty is real. It should be named as such. Some of what appears in the photographs and satellite imagery of Antarctica almost certainly has natural or technical explanations. That needs to be stated clearly and without qualification. Geological processes are real. They have operated on the Antarctic landscape for millions of years, and they are capable of producing formations that look unusual, geometric, and even structured to an untrained eye. Wind erosion, freeze-thaw weathering, pressure ridges, and glacial horn formation are all documented phenomena. They produce real shapes in real landscapes, and those shapes can look striking in aerial and satellite photography. Satellite imaging genuinely has limitations at polar latitudes. Compression artifacts, Stitching errors, reflective distortion, and cover geometry issues are all technically valid explanations for image quality problems. Not every unusual shape in an Antarctic photograph implies an unusual origin. That is a reasonable position, and it should not be abandoned simply because some questions remain open. But reasonableness in one direction does not require abandoning reasonableness in the other. And the honest assessment of what has been examined here is that the natural and technical explanations, while valid in their general form, do not fully dissolve the specific observations that have been identified. The consistency of certain patterns, the selective concentration of image degradation in specific inland coordinates, the recurring appearance of unusually regular formations across independent sources and different time periods, the structure of official responses that address categories rather than specific cases, does not disappear when scrutinized. These things do not confirm anything specific, but they do not dissolve under examination either. They remain present, they remain specific, and they remain without the kind of detailed, case-by-case engagement that would be needed to address them adequately. The selective image degradation is perhaps the most concrete of these persistent observations. The argument that polar imaging is technically difficult is sound, but it does not explain why specific inland coordinates appear consistently degraded across multiple independent reports spanning multiple years, while surrounding areas in similar technical conditions appear with greater clarity. Technical limitations distribute across regions according to the technical factors that produce them. They do not concentrate in specific locations with the consistency that has been reported. That discrepancy between what the technical explanation predicts and what has actually been observed has not been addressed with the specificity it requires. The general explanation and the specific observation do not fully align, and that misalignment is still present. The pattern of official responses that address general categories, without engaging with specific details, is also still present. This matters because it defines the current state of the public record on these questions. What exists in that record is a set of specific visual observations, coordinates, characteristics, comparisons, and a set of responses that confirm the relevant geological and technical categories without demonstrating how those categories apply to the specific cases in question. The gap between specific question and category-level answer has not narrowed over time. It has simply persisted. New observations have been made. New general responses have been offered. The structure has remained the same. And in that structure, the questions that were present at the beginning of this examination are still present at its end, in essentially the same form. What is perhaps clearest from everything examined here is a specific gap that has received less direct attention than the photographs themselves. Antarctica is one of the most scientifically monitored places on Earth. The amount of data collected from the continent annually, climate measurements, ice core samples, seismic readings, atmospheric observations, satellite passes, is enormous. Dozens of research stations operate year-round. International scientific programs commit significant resources to understanding the continent's role in global systems. By the standard of scientific attention, Antarctica is not neglected. It is, in fact, extraordinarily well observed. But scientific observation and public transparency are not the same thing. The data collected from Antarctica flows primarily into institutional channels, national research programs, international scientific bodies, peer-reviewed literature operating within a relatively closed academic community. What reaches the public is a filtered version of a much larger body of information. And the filtering process, what is published, what is accessible, what is explained, and what is not itself transparent. That gap between the scale of monitoring and the degree of public transparency is real. It has been noted by researchers and policy analysts who work specifically on Antarctic governance. It is not a gap invented by people asking questions about unusual photographs. It is a structural feature of how the continent is managed that exists independently of any particular observation about specific images. The Antarctic Treaty System was designed to promote openness, but the practical operation of Antarctic research and governance leaves significant discretion to individual national programs about what information is shared publicly, when, and in what form. The result is a continent that is extensively studied but selectively documented in the public record. That combination, extensive private knowledge and selective public disclosure, is exactly the kind of environment in which unanswered questions accumulate over time. It is also the kind of environment in which assessing the significance of any particular observation is genuinely difficult. Without access to the underlying data, the full resolution imagery, the subsurface surveys, the field reports from restricted zones, it is not possible to determine from the outside whether the unresolved questions point to something significant or whether they would dissolve immediately if that data were available. Some believe they would dissolve, that the full data, if publicly accessible, would show clearly that every unusual formation has a straightforward natural explanation, that every degraded zone has a technical cause, and that every restricted area contains nothing more interesting than the stated justification suggests. That is a possible world. It may even be the likely one. Others disagree. They point to the consistency of the pattern, the way the same types of observations keep appearing, the way the same structure of incomplete response keeps recurring, the way the same locations keep appearing in independent reports, and argue that a body of evidence that would dissolve easily upon examination would have been more fully addressed by this point. If the explanations are simple and the evidence is unambiguous, the reluctance to engage with specific cases in specific detail is harder to understand. The cost of providing a detailed, location-by-location explanation of the most frequently discussed anomalies would be low for any institution with access to the relevant data. The benefit in terms of reducing public uncertainty and preventing the ongoing circulation of unanswered questions would be considerable. The fact that this has not happened consistently across multiple institutions in multiple years is something that both positions need to account for. The photographs that started this entire discussion are still available. They have not disappeared from public databases, though some of the areas they show have become less clearly rendered in newer versions of mapping platforms. They can still be found, examined, and compared. The specific observations they gave rise to, the shapes, the lines, the shadows, the proportions that did not fit the immediate explanations offered, are still visible in them. Time has not resolved those observations. The passage of years has added more independent reports of similar anomalies in similar locations, but has not produced the specific, evidence-based responses that would allow those reports to be set aside with confidence. The photographs are the same. The questions around them are the same. And the explanations, in their current form, are the same general responses that were offered when the questions first appeared. Access to the areas most discussed remains controlled. That is not a new development. It is a structural feature of Antarctic governance that predates the current wave of photographic questions, and that will likely continue regardless of how those questions are eventually addressed. The combination of physical remoteness, institutional control, and treaty-based access restrictions means that independent verification of claims about specific Antarctic locations is not simply difficult. It is, for most researchers outside official programs, effectively impossible. That reality does not prove anything, but it does mean that the current situation is likely to persist. The questions will continue to circulate. New observations will continue to appear. Official responses will continue to follow their established structure, and the gap between specific question and specific answer will continue to sit, unnarrow and unresolved, in the public record. Some believe this is simply the nature of the situation, that Antarctica is a remote, difficult, and sensitive environment where complete public transparency is genuinely impractical, and that the unanswered questions are the ordinary residue of managing an extraordinary place rather than any indication of deliberate concealment. That is a coherent position. Others believe that the difficulty of accessing the answers is itself part of the answer, that the pattern of restriction, incomplete response, and controlled access reflects something about what is actually present in the most restricted areas, and that the difficulty is structural rather than incidental. That is also a coherent position. Neither has been resolved by the available evidence. What remains, at the end of this examination, is a set of photographs that can be looked at by anyone, a set of questions that have been raised specifically and repeatedly, a set of responses that have addressed those questions generally and incompletely, and a set of access conditions that make independent resolution of the remaining uncertainty genuinely difficult to achieve. The mystery of what these Antarctic images actually show, What is beneath the ice in the most restricted areas? What produced the formations that the standard explanations do not fully account for? What motivated the scale of early military expeditions to the continent? And what has driven the expansions of national presence in more recent years remains present. It is not loud. It does not announce itself. It sits quietly in the available record, in the specific details that have not been addressed, in the coordinates that keep appearing in independent reports, and in the space between what is known and what has been clearly explained. That space has not closed. And